Hello everyone. So today's session we will be discussing about the isotopes, isobars, isoelectronic species, isotones, isodiaphers, and isosters. Okay. So to understand these terminologies, let us understand first atomic number and atomic mass number. So let us begin with the atomic number part. Atomic number means what? Atomic number is denoted by capital letter Z. Okay. So atomic number is equal to number of protons in an atom or ion, or atomic number is also defined as number of electrons in neutral atom. Number of electrons in neutral atom. Next terminology is atomic mass, which is denoted by capital letter A. Now, atomic mass means what? Atomic mass is the sum of number of neutrons plus protons. So, number of neutrons plus protons combinedly known as an atomic mass, or it is also known as number of nucleons. Now, representation of atom. Atom is represented by, let us consider X is a symbol of atom. So, X is the atom. Z is the atomic number and A is the atomic mass number. Okay, so this is a representation of atom, where X is the symbol of an atom of an element X. Now, first terminology is isotopes. Okay, now isotopes means what? The species with the same number of protons are known as isotopes. Okay, so P means proton, same number of protons. Okay, that is the value of Z is same value of Z, but different value of atomic mass. Different value of atomic mass. Okay, for example, protium, deuterium, and tritium. So in this, these are the isotopes of hydrogen. So here, atomic mass number is same. Atomic mass number is different, but here atomic number is same. Okay, number of protons are same, but the atomic mass number is different, right? So it is same number of protons. Okay, second example is carbon 612, carbon 613, and carbon 14. Carbon 14. Next example is chlorine 1735, chlorine 1737. Okay, so in chlorine 1735 and 1737, here the atomic number is same, but the atomic mass number is different. Okay, now next terminology is isobars. Isobars. Okay, isobars here we represent what? Both n plus p. This value n plus p is equal to a, and this value is same for isobars. Okay, but the value of z is different. Okay, so for example, argon 40, calcium 40, and potassium 40. Okay, so here atomic number of argon is 18 and atomic number of calcium is 20, and potassium atomic number is 19. Okay, so here atomic mass number is same, but the atomic number is different. Okay, now second example is 14 carbon 6 and 14 nitrogen 7. 14 nitrogen 7. Okay, so these are the examples of isobars where the atomic mass number is same. Now third terminology is isotones. Okay, now isotones means what? Isotones. Here isotones, N means neutron, same number of neutrons, but the value of Z is different and the value of A is also different. Okay, for example, 14 carbon and 16 oxygen. Okay, so here let us find the value of number of neutrons. So in 14 carbon, how many neutrons are there? In 14 carbon, 14 minus 6, that is 8 neutrons are there. 8 number of neutrons. Similarly, find in case of oxygen, 16 minus 8, which is equal to 8, 8 number of neutrons. Okay, so here the number of neutrons are same. Now let us take a second example of isotones. Second example is silicon 30, phosphorus 31, and sulfur 32. Okay. Now silicon atomic number is 14, phosphorus 15, and atomic number of sulfur, we know that it is equal to 16. Now, so let us find the value of N. How many neutrons are there? 30 minus 14, which is equal to 16. In case of phosphorus, 31 minus 15 equal to 16. And in case of sulfur, 32 minus 16, which is also equal to 16. Okay. So here the number of neutrons is same. Okay. Now let us take another example. Germanium 76, 32. Germanium 76, 32, arsenic 77, 33. Okay. So germanium and arsenic. So here let us find the value of number of neutrons. In germanium, 76 minus 32, which is equal to 44 neutrons are there. And in case of arsenic, how many neutrons are there? 77 minus 33, which is equal to 44 neutrons are there. Okay. Now, next terminology is isoelectronic species. So, fourth terminology is isoelectronic species. Isoelectronic. Now, isoelectronic means what? Species with same number of electrons. Same number of electrons. So, electrons number is same. Okay. So, for example, Na plus, Mg2 plus, aluminium 3 plus, nitrogen minus 3, F minus 1, and oxygen minus 2. Okay, so let us find how many electrons are there. In Na plus atomic number is 11. So 11 minus 1 is equal to 10 electrons. In case of magnesium, atomic number is 12. 12 minus 2 is equal to 10 electrons. Aluminium, atomic number is 13. 13 minus 3 is equal to 10 electrons. Nitrogen, atomic number 7. And there's a minus 3 charge on nitrogen. It means 3 extra electrons are there. So 7 plus 3 becomes equal to 10. In case of fluorine, atomic number, we know that fluorine atomic number is 9. 9 plus 1 is equal to 10. Oxygen atomic number is 8. 8 plus 2 is equal to 10. Okay. Now next example is, second example, lithium plus 2, beryllium plus 3, boron plus 4. Okay. Now let us find the number of electrons in case of lithium. In case of lithium, how many electrons are there? Lithium atomic number is 3. Okay. So 3 minus 2 is equal to 1 electron. In beryllium, atomic number is 4. 4 minus 3 is equal to 1 electron. And in case of boron, atomic number is 5. 5 minus 4 is equal to 1. Okay. So these are the single electronic species here. Okay. Next example is of isoelectronic species. CH4, ammonia, water. Okay. Now, in carbon, number of electrons is equal to, carbon number of electrons is equal to 6 plus hydrogen. One hydrogen consists of 1 electron. Okay, so there are total 4 hydrogen. So 4 into 1, 4. So number of electrons in one methane molecule is equal to 10. Okay. Similarly, NH3, nitrogen atomic number is 7 plus each hydrogen atom consists of 1 electron. So 3 into 1 is equal to 3. Total 10 electrons. Similarly, in case of water, oxygen, 8 electrons and hydrogen. Two hydrogen atoms are there, so 2 electrons are there. So total number of electrons in one molecule of water is equal to 10. Okay. Now next terminology is isodiaphers. Isodiaphers. Okay. Now isodiaphers means what? The species with the same isotopic number. The species with same isotopic number. Isotopic number is same. Okay. Now isotopic number means what? Isotopic number means n minus p. That is the difference between number of neutrons and number of protons is same for isodiapole type of species. Okay. Now number of neutrons, we know number of neutrons is nothing but what? Number of neutrons is A minus Z. Okay. So that is atomic mass minus atomic number is known as the number of neutrons. So number of neutrons minus number of protons. Proton number is same as the atomic number. So isotopic number is equal to A minus 2Z. A minus 2Z. So by using this formula, we can easily calculate isotopic number for the species. Okay. So let us take an example. Sodium and aluminium. Okay. Because sodium atomic number is 11, atomic mass number is 23, aluminium atomic number is 13, atomic mass number is 27. Okay. So let us find the value of isotopic number for sodium and aluminium, and let us check the value is same or different. Okay. So for sodium and aluminium, let us find the value of first write the value of atomic mass, then write value of atomic number Z, then find the value of number of neutrons, right? Yeah. So atomic mass is equal to atomic mass 23 for sodium, atomic number is 11. So number of neutrons is equal to 23 minus 11, which is equal to 12. And number of neutrons minus proton, this number of neutrons 12 minus number of protons 11, which is equal to 1. Okay. Similarly, calculate for aluminium. Atomic mass number is 27. For aluminium, atomic number is 13. So number of neutrons is equal to 27 minus 13, which is equal to 14. Now take a difference, 14 minus 13, which is equal to 1. Okay. So here, this isotopic number value is same for sodium and aluminium. So sodium and aluminium, this is a pair hand of isodiapole. Okay. Now let us take another example. Uranium 238 and thorium 234. Okay. So यूरेनियम atomic number होता है 92 and thorium का atomic number है 90. Okay. Now let us check for this example. The isotopic number is same or different. Okay. So let us calculate the values. Uranium and thorium. Okay, so atomic mass number of uranium is equal to 238 and atomic number is equal to 92. Okay, so this difference is equal to 146. So number of neutrons equal to 146. Now 146 minus 92, which is equal to 54. Okay, similarly find the value for thorium. Atomic mass of thorium is 234 and atomic number is 90. So this difference is equal to 144. Okay, so number of neutrons for thorium is equal to 144. Now 144 minus 90, which is equal to 54. Okay, so now here also the isotopic number value is same for these two species. Okay, so these two species are example here of a isodiapole. Now next terminology is isosters. Isosters. Isosters mean what? The species with same number of atoms. That is, atomicity is same. atomicity is same, and number of electrons same. Atomicity is same and number of electrons same, right? Like for example, N2O and CO2. Okay, so here atomicity of N2 is 3 and CO2, one carbon atom and two oxygen. So CO2 atomicity is also equal to 3. Now let us find electrons. So in N2O, nitrogen 7 into 2. Okay, that is 14 plus oxygen 8 electrons. Total number of electrons 22. Carbon 6 plus oxygen. So number of electrons here also is equal to 22. Okay, so per molecule, number of electrons per molecule. Okay. Now next example benzene and B3N3S6. Okay, so benzene and B3N3S6. Here also the number of atomicity. So first calculate the value of atomicity. So atomicity 6 plus 6, 12. 12 atoms are there in benzene. And this compound is known as what? Inorganic benzene. Inorganic benzene, because its shape is same as benzene, planar. It is a planar molecule. Inorganic benzene, also known as a borazine or borazone. Borazone. Okay. So let us find the value of atomicity. So 3 plus 3 plus 6. Okay. So how many atoms are there? Here also total 12 atoms are there. Now let us find the electrons. Number of electrons in benzene. One carbon consists of 6 electrons. Okay. So there are total 6 carbon atoms. So 6 into 6, 36 electrons in carbon, and hydrogen 6 electrons. Okay, so total number of electrons 42. In inorganic benzene also the number of electrons is equal to total electrons in inorganic benzene is equal to 42. Okay, so this is about the isosters. Next example is N2 plus CO. N2 and CO. Okay, N2 and CO pair. Now here atomicity in N2 total number of atoms is equal to 2. Atomicity 2. In CO atomicity is equal to 2. Atomicity. And let us find electrons. In N2 how many electrons are there total? N2 14 electrons, and CO 6 plus 8 14 electrons. Okay, so number of electrons are same. Okay. Okay, so now we'll discuss the questions related to these terminologies. So question number 1 is atomic number and mass number of element X are 25 and 52 respectively. The number of electrons, protons and neutrons in X plus 2 ion are respectively. Okay. Now X plus 2 ion is given to us. So first let us find the electrons. Electrons in X plus 2 ion. So total atomic number, the atomic number is 25. So 25 minus 2, which is equal to 23 electrons. Okay, because plus 2, the charge on ion is plus 2 here, means 2 electrons are less. So total number of electrons is 23. Now let us find the number of protons. Protons number is equal to 25 and the number of neutron is equal to atomic mass number is 52 minus 25. So number of neutrons is equal to 27. Okay. So correct option is first option. Now second question. The number of protons, electrons and neutrons respectively in the given element. Okay. So here number of protons is, the proton number is 93. Then number of electrons, the species is neutral. So number of electrons is also equal to 93. And number of neutrons is equal to, number of neutrons is 237 minus 93, which is equal to 144. Okay, so correct option is second option, proton, electrons and neutrons. Okay, so now let us move on next question. Okay, so question number 3. An element with a mass number 81 contains 31.7% more neutrons as compared to protons. Assign the atomic symbol. Okay, so let us consider mass number is given to us. Okay, so mass number, that is a value of A is given. A is equal to 81. Okay, and it is mentioned that element with mass number 81 contains 31.7% of neutrons as compared to that of the protons. Okay, so let us consider number of protons is equal to P. So we know that number of protons plus number of neutrons is equal to 81. Okay, which is equal to atomic mass number A. Now, number of protons, now it is mentioned that number of neutrons are 31.7% more than that of the number of protons. Okay, so number of neutrons become equal to proton plus proton into 31.7 divided by 100 equal to 81. Okay, so let us solve this. Let us take proton is common number of proton. So 1 plus 0.317 is equal to 81. Okay, so proton into this is equal to 2.317 is equal to 81. So number of protons is equal to 81 divided by 2.317. Okay, so 2.317, which is equal to approximately 34.9, so close to 35. Okay, so we know that 35 is an atomic mass. 35, not atomic mass, it is the atomic number of the species. It's the atomic number of bromine. Atomic number of bromine. Okay, so second option is. Question number 4 is, an ion with a mass number 56 contains 3 units of positive charge and 30.4% more neutrons than electrons. Okay. Now, so let us consider the number of electrons is equal to x. Number of electrons is equal to x. So number of protons become, because the ion is given x plus 3. So in x plus 3 ion consists of x number of electrons. So how many protons are there? So protons number is equal to x plus 3. X plus 3, because number of electrons in x plus 3 ion is equal to x. Okay. Now, so number of neutron is equal to 30.4% more neutrons than electrons. So number of neutrons is equal to x plus x into 30.4% more neutrons than that of the electrons. So it is equal to 1.304x. Okay. Now we know that sum of neutrons plus protons is equal to atomic mass. So let us substitute a value. 1.304x plus number of protons is equal to x plus 3 is equal to atomic mass is given to us 56. Okay. So 2.304x is equal to 56 minus 3. Okay. So which is equal to 53. 53. So x is equal to 53 divided by 2.304 approximately is equal to 23. So value of x is equal to 23. Okay. Now, so x is equal to 23. So the number of protons is equal to. So let us find the number of protons. So number of protons is equal to x plus 3. So x is equal to 23, 23 plus 3 is equal to 26. And 26 is the atomic number of iron. Atomic number of iron. So given species is Fe3 plus, Fe3 plus. Okay. Okay, now let us move on next question. Question number 5. Question number 5 is for practice. Okay. So solve this question and write the answer in a comment section. Let us move towards question number 6. Question number 6. Now question 6. The average atomic mass of sample of element Y is given to us 16.2 unit by the mass. Okay. Then what are the percentage isotopes of the isotopes 16Y8 and 18Y8 in the sample? Okay. Now here there's one formula which is related to the isotopes average atomic mass. Average atomic mass of isotope is equal to average atomic mass of an isotope is equal to, it is equal to summation of percentage abundance into atomic mass, atomic mass of isotope divided by 100 divided by total percentage. Okay, so we'll use this formula to calculate average atomic mass for isotope. Now, let us apply this formula. Let us consider there are two isotopes are given now. So let us consider for one isotope, its percentage abundance is equal to X. Okay, so let us consider for 16Y, 16Y isotope, the percentage abundance is equal to X percentage. And so for another isotope, the percentage abundance become 100 minus X, right? 100 minus X percentage. Now let us apply this formula. Now, so percentage abundance is equal to, the value is given to us. Total percentage abundance is equal to, let us check the value first, 16.2. Percentage abundance is not given, so average atomic mass is given. So average atomic mass is equal to 16.2 is equal to percentage abundance of first isotope है 16. 16 is the atomic mass and its percentage abundance is equal to X. Plus second isotope 18 atomic mass and its percentage abundance is 100 minus X divided by total percentage 100. Okay, so let us solve this. 1620 is equal to 16x plus 1800 minus 18x. Okay, so which is equal to 1800, 180 is equal to 2x. So what is the value of x? X is equal to 90. X is equal to 90, which is a percentage of, which is a percentage of lower isotope. Means this x is equal to 90%, and 100 minus x is equal to, that is 100 minus 90 becomes 10%. Okay, so lower isotope 90% and higher isotopes is 10%. Okay, now next question is question number 7. An element of atomic weight Z consists of two isotopes of mass number Z minus 1 and Z plus 2 Z plus 2. Percentage abundance of heavier isotope is. Okay, so here also question is based on same formula. Average atomic mass is given to us. Average atomic mass is equal to Z. Z is equal to. Now let us consider percentage isotope of one. First isotope is X and second isotope is 100 minus X percentage. Okay, so now substitute a value. Atomic mass Z minus 1 into percentage abundance X plus second isotope atomic mass Z plus 2 into percentage abundance 100 minus X divided by total percentage is equal to 100. Okay, let us solve this. 100 Z is equal to Zx minus X plus 100 Z minus Xz plus 200 minus 2x. Okay, now here 100z will get cancelled, then xz, next terminology is xz and minus xz will get cancelled. So 200 is equal to, remaining term 200 is equal to 3x. So x is equal to 200 divided by 3. Okay, so which is equal to 3 6 are 18, 2 3 are 18, so 66.6 percentage. Okay, so these are the percentage isotope of what? Percentage isotope of lighter isotope Z minus X. Okay, so what is the percentage of heavier isotope? So percentage of this heavier isotope is equal to 100 minus X. That is 100 minus 66.6, which is equal to 33.3 percentage. The percentage of heavier isotope is equal to 33.3 percentage. Okay. Yeah. Next question is for practice question. Okay. So write the answer for this question. Solve this question and write the answer in comment section. Next question. Question number 9. Which of the following pairs is our isodiaphers? Okay, now isodiaphers, we know that isodiaphers they have same isotopic number. So let us find the isotopic number. So isotopic number means what? N minus P, which is equal to A minus 2 Z. This value. So let us find this value for carbon. Let us find A minus 2 Z for carbon. So carbon 14 atomic mass is given, and Z is equal to 6. So 2 into 6 is equal to 2. For sodium, second sodium 23 atomic mass is given. 23 minus 2 into 11, which is equal to 1. Okay. Next is magnesium 24 minus 2 into 12 equal to 0. Next is helium 4 minus 2 into 2 is equal to 0. Next, oxygen is given. 15 minus 16, 2 into 8 is equal to minus 1. Next example is chlorine is given. 19 minus 2 into 9 is equal to 1. And carbon 13 minus 2 into 6, which is equal to 1. Okay, so here for this last period, the isotopic number value is same, is identical. So fourth one is the correct option. Okay, now question number 10 is for practice. Which of the following pair is isodiaphers? Go through the option, solve the question, and answer in the comment section. Next, question number 11 is also for practice. Question number 12 is also for practice. Thank you everyone guys. Thank you so much.